Good morning, everyone, and welcome to this Graitec BIM Designer Concrete Series webinar this morning. Thank you very much. Thank you, everyone, for joining me. For those of you who are not familiar with me, my name is Jonathan Hand. I'm a Customer Success Manager with Graitec. I'm also an Autodesk Expert Elite. Within Graitec, I predominantly sit within the structural team, and I looked after core products such as advanced steel, Revit architecture, Revit structure, and also the Graitec suite of tools. And today we're going to take a quick look at the concrete series and the range of tools that we have on offer today. So, as I said, the one we're going to look at this morning is a quick look at the concrete series, which allows us to automate reinforcement detailing within the Revit platform. At Graitec, what we're trying to do is to connect the BIM workflows with regard the structural disciplines, and we have a range of products that suit various Autodesk products. At the center we have the Advanced BIM Designer suite of tools, and then that is flanked by our Advanced Design, which is our FEM analysis package. Then we have our Advanced Power Pack for Autodesk Revit, and then we have the Advanced Power Pack for Autodesk Advanced Steel, and then for steel fabrication and management we have our own advanced workshop. And what we're trying to do is use these range of softwares and platforms to connect the BIM workflow, so to take it from concept to production as such. So what we're looking at today is what we call sort of the next generation of BIM, and we're trying to automate the structural process. And in this case we're going to use the Advanced BIM Designer to automate rebar and reinforcement within the Revit platform. So within Revit, you probably already know there is a range of tools that allow you to add reinforcement to the model. And what we've done is we've created our own suite and a set of tools which further enhance and automate the manual processes within Revit. So the first thing that we can do is we can automate the placement of 3D rebar within the model. This can, where possible, be connected to FEM results. So if you've got, for instance, a Graitec Advanced Design, you can link and load in the analysis results, which will then automate the production of the cages based upon the analysis results. The next step we then do is we automate the views and the drawing sheets, which, as you probably are aware, is a little bit time consuming within Revit, but our BIM Designer allows you to select a hosted element and automate the production of the detailed views complete with annotation. And then we also annotate the bill of materials and the scheduling, and they are automatically placed upon the views. And then coupled with that, if we're linked into an FEM report and analysis, we can output the design reports. So what we're trying to do is further enhance this complete modeling process as the structural world gets intertwined into the BIM workflow more and more. So it's just a multiple platform, multiple workflow solution, and that's what Graitec are trying to achieve by connecting all the different disciplines and the different parts within structure. So that's sort of enough of the PowerPoint. Not to bore you to death, I'm going to jump straight into Revit. I'm using Revit 2018.1, which is the latest release, and you can see that it is just pretty much your bog standard Revit out of the box. But what Graitec have done, we have created a new suite of tools called Graitec Concrete Design. And this is where you find all your added tools to automate and detail reinforcement. It's a simple add-on. You can just download it, it installs, and it simply puts a new ribbon on top of your Revit platform. Coupled with that, you've probably heard me mention the Graitec Power Pack. This is free to all Graitec subscribed customers, and it's just got an extra range of tools that basically Revit just doesn't have. So we listen to all our customers, we take the feedback, and because we're also a developer, we can develop add-on tools, things like a link, bidirectional link in and out of Excel. We have the ability to add parameters, put in openings. We have the ability to apply and reorganize numbering to any type of element or family or component or parameter within a Revit model. But we're going to obviously concentrate within the Graitec Concrete Design. So I'm just going to switch to a 3D view that I've pre-prepared. This is just pretty much a standard building. Now, The Graitec concrete design gives us the ability to automate, at the minute, 3 types of components or families within Revit. So we can automate the reinforcement within a footing, a column, and a beam. We are working on slabs and walls, and then thereafter we'll work on stairs and complete the process. But at the minute, the designer that you're looking at today can automate footings, columns, and beams. So the big thing that we've looked at with the BIM designer is, first of all, that we can localize the product. So we can work to actual localization codes and to the EC codes within the UK. So if you look at the localization settings, we can change it obviously if you're in a different region. So it's not just UK specific. It can work with lots of different areas. Then with each one, we can then change the standards that we work to. And again, the reinforced concrete, and then our general settings. So the thing that we do first and foremost is we localize the product. So to jump straight into it, I'm just gonna quickly zoom in on a particular footing. We have a little look at this. So what we're going to concentrate on today is we're not going to link this at the minute to an FEM analysis package. That will come in a later webinar next month, where I will connect it to an advanced design, where we'll export it out from Revit, analyze the model and take the loads, and then analyze them back within the Revit platform. But today we're just going to look at the functionality within, just from a detail point of view within Revit. So if we're using Revit just to detail reinforcement. So the first thing that we do within the concrete design is that we can use a list of assumptions of how we would like to automate reinforcement. I know that within Revit, I can select the element, go to structure, and I can manually place reinforcement based upon elevation views, but it's all a manual process. With the Graitec concrete design, we can build up an area of assumptions to assume a standard of how we would like to do something. So I'm just going to select this footing, go to concrete design, and I'm going to look at the assumptions panel, and we see that first of all we have design assumptions, and this allows us to load in standards that we would like to use when we want to automate the placement of reinforcement. So we look at general assumptions, where we can look at safety factors. I've got a series of tabs where I can default now as a standard across my project to say that I want all concrete covers to be 40 millimeters, and then I can also change the concrete covers for the footings, top and bottom face. I can change minimum cover verifications. I can look at general design assumptions like minimum area reinforcement. Do I want earth loads? Am I looking at EC7? So what is the design approach? Do I want to change it? Is there a pressure distribution? What annex am I using? Are we looking at some sliding issues? So again, you've just got some standard stuff. Same for the seismic, and again for the reinforced concrete, what the ductility is. Are we looking for exposure classes? So all this sort of sits sort of like within the Revit template that's saved as a default, that is the design assumptions that we're using. So not only can we assume the design assumptions, we can also look at the reinforcement. So if we look at, you can see that it's got a fly out, and I can select it and go reinforcement assumptions, and you can see that it looks at a dialog box where it tells me that it is indeed a footing, and in here I can start to automate and say, within this footing, this is the type of distribution that I want. So I can look at my minimum spacings, my maximum. Am I reinforcing with a cage or not? And if I am, I can choose the diameter of the bar, and then I can also choose how I want to hook the angles. So in this case, I'm going to go with reinforce X and Y, 10 mil bar, and I'm going to hook like that. We can also look at what type of hooks do we want. Are we looking at rectangular reinforcement? So if there's a column above, which in this case there is, are we using starter bars? Yes or no? And what's the anchorage length? So again, you just assume all the standards that you would within the footing. Also within the reinforcement assumption is the bar stock. So we can actually control what bars we use, what do we want to use for certain things. You can see you can actually tick on and off what you want to use, what you don't. So what is your preferred bar length? What do you actually have in stock? And again, you can reset it back. So again, with that, you've got the design assumption, the reinforcement assumption, and then you control it with the bar stock. So if I select this element, just to show you how quickly and easy it is. So within Revit, I could probably reinforce that within probably 3 or 4 minutes. Select my detail view, go in elevations, and then do it. But with the BIM designer, with the assumption set, I can simply go to the calculate section, and this allows me to automate the reinforcement within the element. So you can see that it has done a foundation of 14, it's given it a mark, it's given it a GTC ID, and it's calculated it okay. And we go in and we have a look, and you can see that based upon the design assumption and the reinforcement assumption, it has went in and simply placed a shape 51. It's looked at the hooks, it's looked at all the standard information. So you can see that very quickly I can look at this element and I can just simply click calculate, and it will do a similar process where it will go in and reinforce the settings. So that's with design assumptions. You can also, if you don't know your design assumptions, you can just select an element like this, Graitec concrete design, and look at, instead of looking at an assumption and calculating based upon the theoretical assumptions, we can look at just the reinforcement, and we can manually just reinforce this footing. So this brings up a dialog box, but you can see that everything is blank. Okay, so you can see that it's brought it up as a footing, and this is where it allows me to manually automate the position of the bars. So I can say that I want a quantity of 10. I've clicked enter too soon. I can say I want a 10 mil diameter, spacing 50, and you just go through the settings, and you can see that you can close the links on the X and the Y. So we could say we want 10 bars in that direction, and you can see that once you click enter, that it takes that settings and it will go in. So you just fill out the values that you need, and then it updates and changes the reinforcement each time. So it's sort of a manual reinforcement, but they're also automating the position of the bars. We select the element again, and you can also do that for a component that's already done. So if you want to change something without using the assumption, just go to reinforcement, and you can see that all the values have all been set by the assumptions, but you can go in and also override. You can also look at the longitudinal reinforcement settings. You can see that it's put them in there, and any supported elements and link bars and anything that we may want to change. So you can see that we're starting the process of automating the placement, which is the sort of slow, time consuming bit. If we look at a column, it's the same process, concrete design. We again have design assumptions. For a column, you can see that the dialog boxes change for each different type of element that we have. And we also have the reinforcement assumptions of the column. Actually, that's a footing that looks like. If I select the column, reinforcement assumptions, you can see that the dialog boxes change for the longitudinal traversal, whether we've top starter bars. So with your assumptions done, concrete design, calculate, and you'll see that it indeed has placed all the bars the way that we want them. If I select this, I can then just simply click calculate. Okay, so what we're doing is we're automating footings, columns, and also beams. So if I select the beam, again, process is still the same. If I want to change the assumptions, it will go in, have a little look. You can see that it becomes a beam. And with the beams, there's a little bit more in it because we've got the anchorage, we've got the anti-crack, we've got supports, splice bars, and again, all dialog box driven. Simply tick on and off what you want. So we can select this element, concrete design, calculate, and it will simply place the reinforcement within the element. Okay, so to take this all a little level, so that the thing that we're trying to achieve is automate the placement, whether it be based upon an FEM model, or in this case based upon a design assumption. We're just trying to speed up and automate the process. The second step to that, as I noted on the PowerPoint, was the production of the drawings, which again is for me is a hugely time-consuming thing when I'm doing lots of reinforcement. That I have to produce a detailed view of each one, I then have to annotate it, I have to dimension it, and then I have to schedule it, and then I have to drag them views to my sheet. So what we've done is we've created a system where we can automate the production of the drawings, and this is done through the drawing settings. As I said, we've got beams, columns and footings. We automate the position onto a title block, and then we can automate it onto a schedule. So to show you the process, I'm just going to cancel that. I'm going to select this footing, Graitec concrete design, and I go straight to this button, which is called generate the drawing. So this will generate all my sectional views, place them on a sheet with a schedule. Because I'm in the latest Revit, it's actually taken a 2017 template file and just updating it, but that's a one-time operation that you probably get quite a lot. And you've seen the screen flicker there a couple of times. So what it's done, it has automated these 4 detail views, and it has also created a sheet. So if we just minimize that a little bit, we'd double click straight to the sheet. What it has done, it has as best tried to place the detail views on the drawing. So we've obviously got, this is just a standard Revit family for a title block. So if we'll take a look at it, we have detail 1, and if we reference that back, that is the elevation here. So you can see that it's produced a detailed view. It has put a dimension with a multi-rebar tag. Let's give it a scale and a size. So it's given a view there and there. So you can see that's tagged. Now these are all Revit components. So that's just a detailed view. And if we just look into each of the views, you can see that that is just a dimension style. That can be your dimension style. It can be a new one. That is just a multi-rebar tag. So again, just standard Revit families. All we're automating is the process to create these and place them onto a sheet. So don't worry too much what it looks like thus far, because this is just a pretty much a standard template file. What we find is that when companies go and adopt this process, they integrate it into their current Revit platform. So they will automate their own tagging and annotation views. So you can see you've got all that, and then more importantly up the top we then have a schedule of the rebar. So you can see we've got the bar marks, the size, the number of members, and then we have shape codes, and we've all done it to the BS 8666205 code. So if you go back to our 3D view again, we can look at a different type of element. So if I want a drawing of this, it's the same process, generate drawings. So it creates the views, and then we'll add a new sheet to my project browser, and there I have detail 12. So I've got my elevation view and then my sectional views through the component, and then we have our standard schedule. And again, this is just standard families that you can choose and automate as you want. So if we go back to my 3D view by a level, so you can see it's pretty easy to use. The other thing I want to show you today is that we can obviously work within design groups. So I'm going to select this. So I've selected these 5 footings. I'm going to create them into a design group. So let's just take this and this. Ooh. So I'm let's take these 5 footings, concrete design, and I can create a design group, and this allows me to group these all together so that they can all be calculated and detailed together. I'm going to just call it my JH group. I'm going to select OK. So what that means is that these are now linked together. So once I calculate one, so I can select this element, concrete design, and click calculate, it will reinforce the 5 with the same design assumptions. So you can see we can start to group elements together. So once we select this guy, concrete design, generate a drawing, this will generate one drawing of the 5 components, but it will change the schedule to reflect the design group that I've just created. So you can see that we now have a new sheet with my group on it. We double click into it, and you can see then the number of members is 5, 5, and 5. You will also see up the top we have a list, number of elements in this group is 5. So you don't need to worry about multiple components that are the same that need to be updated and changed. Another key thing that we've worked on is, if you're using Revit quite a lot, is the ability to change the size of a particular component. So let's have a look at this footing. Currently that is a Revit family. We know that we can edit the type. We could duplicate it, and I could say that is 25 by 25 by 25 millimeters, and then I change each of the settings. But again, quite a lot of work and a manual process. And then I can click OK, and that will update the size of this footing. But what we have within the concrete designer is the geometry button, and this allows me to automate very, very quickly. So I can say 3 meters wide, 3 meters wide, 750. Select OK. That has immediately updated the family, and you can see that it has quickly duplicated it, renamed it, and changed its geometry parameters, which I can then select, calculate, and I can reinforce based upon that element. It's a really, really quick thing. That is one of the most useful tools just for standard modeling, to be able to just update and change the size of a particular component. That works for all elements that we can select. So we can select that, and we could do the same process. I'm just going to switch my 3D view to one of a pre-prepared, just cut out section of a concrete beam. So I can select it. Again, we know that we have the design assumption, so I'm just going to quickly click calculate, and you will see that it will place the reinforcement within the beam. So there we are, we've placed all the reinforcement. Well, let's say for instance I want to put an opening within the beam. So we can go to concrete design, we can click geometry. So this is now a little bit more intelligent than just changing the size of a footing, because I can obviously change the width and height of the beam. But if we look at, I can change its sectional properties. But what I want to look at is I want to place an opening. Select my plus sign. So this is opening number 1. So I want over 500, let's say why we want up 100, and we'll go with a length of 500 and a height of 200. So you fill out some basic properties, select OK, and that will update the geometry of the beam. You can see that is now put a hole. So for those of you that use Revit on a daily basis, you can see how quick and easy that is to do, and how awkward that can be to do within just standard Revit. So then it's concrete design, just change it to calculate, and that will update the reinforcement around the opening. You can see that's done all that. And if I want my drawing, concrete design, generate my drawing. As you can see, the speed that we're starting to bring to reinforcement detailing. Although yes, it is just for beams, columns and footings, we will get slabs, walls, and then we will take it further and further. So just select my footing, and we generate the drawing. So we look at detail 15, and there I have my detail view, my sections, and my schedule. And again, these views and details are all done upon a Revit template. So if we explore that a little bit further, so within the system we have a range of Revit templates. So if we go to users and I just browse into where everything is stored within the system, I'll just give you a bit of an insight. So we look at the Graitec Advanced BIM Designers 2018.2 templates, and then we look at Revit. So everything is based upon a Revit template. So there's nothing new, we're not using any different technology that you can't use. And if we look at the drawings 2018 and the UK versions, you can see that we have a template for beam, column and footing. And if we look at the beam template, you can see that it's a standard template file, and this is where we control how it's going to tag. So if you want to start changing how it's going to tag, you can change the multi-rebar annotation. So again, just standard families all sitting within it. We show you how to do all this, of course, but everything is based upon these templates, and then that is what drags and creates the detailed views within your drawings. If we look at this, this again is just a template where we edit the family. You can see that it's just a standard title block with a standard tags and annotation and stuff that you would normally expect. So if you go back and we look at this again, so that's pretty much an insight into where we're going, how we're automating. As part of that, we have a full range of tools just to help you working day to day within just a reinforcement environment. So a big thing is obviously the visibility of the reinforcement, and we've got this tool here called rebar visibility. So I can select it and I can say I want everything hidden, or I can line or solid. So I just say hidden. I can change it based upon rebar fabrics, areas or path. I can change it for the active view of the project. So I can just say I want everything as a line, select OK. You see how quick that is changed my complete model. So it's just rebar visibility. I want everything 3D solid, select OK, and then we're back to the 3D solid. So you can see that is just a massive time saver just on a visibility point of view. But we can also look at where we can change the traversal distribution. We can, lots of other tools just for changing the rebar sets, the numbers, scheduling, lots of little things that we can automate and work towards. So one final thing before I finish is that we can select this element and we can produce a report. So if we're working with an FEM model, we can give a design report of that element. So just let my system whirl away a little bit, and it will produce a report to say what is designed, what isn't designed, and what the the components within it are. Just let it hopefully catch up with me. So it is generating the report. It's just taking a little bit longer than I had expected. So let's let it run, hopefully. So while that's running, so this technology is available now. You can get it on your machines. It works on both Revit 2018 and Revit 2017. So if you've got either, if you get an install of it, it will install the required version on whichever version that you have. I'm going to open the session out to some questions. If anyone's got any questions, just basically just fire them out and type them into me. If anyone wants a trial of this software, I can give it to you today. Just drop me an email. So it has eventually caught up and run a report. As you can see that it's quite an extensive report for the group of objects with all the materials, the concrete covers, the bearing pressures, and it will tell you where it has passed, what it hasn't passed, whether it has failed, and it obviously gives you the stresses. So it's quite an extensive report that you will want. But back to a trial. If you drop me an email to jonathan.hand@graitec.co.uk, I can organise to get you the install, the trial up and running. I can give you some documentation. I can then come and see you, show you how to use it a little bit more in depth. But we have successfully got it out to quite a few companies now. They're using it nearly on a daily basis on lots of their projects to automate the reinforcement. We do think we are going in the right direction with this to speed up the reinforcement detail and bring it into a 3D BIM environment where we can have it sitting with all the other Revit components. Okay, so I'm just going to finish up this webinar now. If anybody has any questions, my email is jonathan.hand@graitec.co.uk. Myself and my colleague Tom White will follow up with each of the attendees just to see what they thought, if they would like any next actions of it in the next couple of days. The webinar is being recorded and will be uploaded to YouTube within the coming days, so we can share that with you as well. So just to finally finish up, thank you all for joining me. I do put one of these on every couple of weeks, so just watch out for the Graitec website or the emailers that fly around. On my next one, I will probably be looking at the precast environment, looking at the new Autodesk extension coupled with the Graitec concrete design to do reinforcement and precast within the one Revit model. As I said, just reach out to me. I'm in Graitec in the UK, so just drop me an email, ring the office, find me on LinkedIn with any questions, and thank you all for joining me.